of the animal. Look, for example, here. First of all, we can classify them, or we do the entropy. We try to, if you want, is to just by the color. You see here, if the color is yellow, we go in this direction. If the color is not, we go in this direction. Later on, the high is equals to 10 or bigger than 10. And you can be easy to classify. So this we call it decision tree. So let's example here. Sorry. So decision tree, you have to, here how many we have? X and Y, right? 2 variables. First of all, I try to choose X or Y, doesn't matter. Let's do for X. And we try to do the entropy. Here will be the separation, the maximum gain. If we do on Y, is here. Now we can say, do we need to do more? Look to we separated to 3 regions. Do you think the entropy for all regions are 0? Of course not, except the first one, this one. Yes. So here, we don't need to do any decisions. Those 2 here, we can say, let's do for the biggest one here. We do here. Do we need to do more? No. If you do more, maybe you will be in the overfitting. So you have to be careful. So we can say, maybe at least we can add here, is more important. Here also. Those are few, is more enough to stop here. So what does that mean? You have to do a lot of decision tree. But how depth you have to go, it depends on the overfitting. Okay? How to control the overfitting? You have always validation. Remember the validation, right? To check if you have this okay or not. Example here. We have class small, medium, tall, and we have 2 features, gender and height. Can you please do the decision tree here? First of all, do we need to start with gender or height?
Gender.
We don't know. Just like this. Let's do both scenario, and we try to say which one is better. If we do the gender, it will be something like this. But I will explain in a few seconds. Okay, this is my things. I will separate them to increase the things, female alone and male alone. You can see here, still have classes are mixed, yes or no? And here class still are mixed. So we need to introduce the second features, which is the high. Based on the high here, can we do disaggregation here, Paul? Here you can see, if it's less than 1.5 is small, if it's bigger is medium. Because here what we have only 2 classes, small and medium. Here what we have here, small, medium and tall. So here we need maybe more, 3 things. So at the end, we have all single class. So this we call it decision tree. But until now, decision tree is still open problem. If you have 20 features, which one is the first? Which one is the second? Which one can repeat it 2 times? What is the depth of it? So it's still open problem. If I do the opposite, start with high, and after do gender, after to be decisions here. It will be in this way. So in this example, there's no much differences, but other example can be real significant. Example here. How many features we have here from the data set? 4 features, right? How many classes we have here? 2 classes. So here there is questions. Do I have to start with A1 after we go to A2, after we get A3, A4, or maybe A3 first, A2 4? So there is 4 factorial combinations. You see here? Imagine if you have 20 factorial combinations, which one is the best? And maybe there is repetition too. So it's still open problem. So usually when they do it as a random forest, they take randomly another choice. And so what is random forest? It's just multi-decision tree, nothing else. Okay, here we did it. This example we solve it. Okay. Let me go to another examples. Did we solve it right? Okay, here for example, please. What do you think? The point at the middle, it will be the class is B or A. What is the size What is the size of A? The size of A is too big, right? The size of B we have only 4. And the other one we didn't say, right? Okay. Okay, what is the covariance matrix of the 3, of B? Is it diagonal or not?
Yes.
Diagonal. A? Diagonal. A diagonal with the same values, right?
But the variance of A is bigger.
Sorry?
The variance of A should be bigger, right?
Yeah. So they have almost the same.
Slightly bigger. I'm looking. I guess it should be B.
Anyway. Look here, please. So we can say the covariance matrix are almost the same, right? The values are almost the same. Look here, please. But what is the probability of give me the point or the data? It belongs to the no, the opposite direction. Sorry, we have to calculate this one against this one, right? Class A giving the point, yes, versus the probability of class B giving the point, right? Yes, we have to calculate this one. What is this one here, please? Do you equate this one, right?
Yes.
Yes, over the probability of the point, doesn't matter. What is versus here, please? Over the point, yes? So the probability of the point doesn't significant. It's the same thing, right? Because we want to compare both of them. So this one don't need, this is no need, right? What is the probability of A? A maybe is, I don't know, maybe is roughly around, maybe the size, you can say roughly, okay? Just 9 out of 10. And this is 1 out of 10. It's 10 times bigger than this, okay? Okay, those here, the probability are almost the same, right? The same distribution, right? So if we cut like this, we can see it in these directions. Both of them, they are almost the same. Maybe this one is a little bit like this, yes, but almost the same, right? But look here, these are the probability of those two. But here I have to multiply it 1 by 9 out of 10, and the other one I have to multiply it by this one. So B is the red one. So what will be here, please? It will be small, yes? So B, it will be something? Is it clear? Because we multiply it by. So at the center, this is exactly my point, right? What is the probability to be red? What is the probability to be blue? Which one is higher? The blue. So this belongs to what?
A.
To A. You got the idea? So they have the same thing, but I'm cutting it. Here there is a Gaussian distribution, there is another Gaussian distribution, but A is multiplied by 1 out of 10, it's very small, and this one's still high. So the probability at the middle belongs to A, 9 times bigger than probability of A. Why? In planet idea, the gravity can take it more, okay? It's more weight of it.
Where we can find the point that it's much higher to be B, not A.
Excellent questions. Which position that we can find equals to B? None. It's almost very small. Because probability is very small B, you see it, compared to A, right? It's better to have anything classified as A, you have high accuracy. Because exactly, unbalanced data. Thank you. Excellent, yes. Let me give you another example. This we did it last time. Coming back to it. Okay, this one is a nice problem. Here, can you read and tell me what do you think? So in the minor and final exam to be something like this, similar to this. Okay, there's no much calculation, but you have to understand the meaning and the concept. Look, for example, class 4. I have class 4 here. They give us example here, right? We have two classes here, But to classify them with the minimum number of ellipse or circle, here we need to have this is together, and here alone, 2. So we need three distribution, right? Or 3 different classes. This one here, what is the minimum that you want to do it together? At the point A, we would like just to check the questions training. We have to have 0 training error. To do that, we allow the classifier to divide to more of 2. However, for each classifier, 3 must be subset of A complementary. For example, okay. So, question 1: what is the minimum of subclasses that you need to do to classify them nicely?
One separate,
2. How you do it? We can do it by 3 or not. We can, right? Look, we have the class here, and another one here, and another one here, right? How you can classify them? By 3 we can do it, right?
Yeah.
By 3 classes, every one, 1, they are separated, there is no overlapping, is fine. Or, I can consider this one as 1, and this is 1. They are separated, is fine. Minimum is 2. Go to the next one. How many you can do, please? 2. How many you can do, please? How you do 2? But you have to have 0 error. 3? 3, yes, you can do 3. But question, can we do less? So if I take this one, look here, this is the first one for the cross. And I do this one for this one. Do you think there is error classification or not? Tell me why, yes or no?
yes.
There is error?
But at the subset is okay, they said that. That is the subset.
Okay, but there is, he said one very important information. The size of A and B, they are same, right? We would like to learn to classify this 0. For example, point A, 2, classification. Okay, so they are almost the same. Oh, say we can say double. It's okay, double. Okay. So, do you think we can do it here or not? So, if you look to the B, to the blue one, is it the value is small or bigger? Okay, let's cut here. Okay, cut here. Guess we cut here, and we see. So I'm looking for my answers here. Okay, this is the one, and this here, right? I'm cutting here to see. Okay, for the blue one, what do you think? Are you okay with this one? Yes, because it is ellipse, right? The red one. Because the value is small, so it should be. Okay. So here, if we are in this region, for sure we classify correctly. We classify it correctly, and here also we classify it correctly again. Of course, because the probability the red is higher. Because more the value is small, more is tight, going to up. You got the idea?
But it's only a probability higher, not. It doesn't mean that it's pure.
Because our classifier is looking to the probability at the end. This is our idea. Of course, this is how to do it. Probability most likely. Okay, last one. Last one, what do you think? Can we do it in 2 or 3? In 2, yes. How they will be? 1 and 2. The overlapping, it comes, they are the same probability, but it is empty regions. So yes, we can do it on 2. Look at the first one, it's easy to explain. The second one is this one. You see here, when you do the cutting, so it's the red one. And here, yes, look at the overlapping, you see here? Here it's classifier C1 and C1 at the tail, C2 and C2, and the middle is empty, so it's correct. So all of them we need 2 only. Clear? So please try to think about something is going up, and here try to cut to look for the probability.
So doctor, can you go to the previous slide? And this figure 2, how will we classify new data?
Here, this one, right? Okay, look to the green one. Here. The green one is something, probability is going up. The red one is flat. If you are at the middle, the probability is belong to the green one, is correct. When they are at the tail, the red one is bigger than the green one. You want is go directly to zero quickly. So it's exactly here. If you see here, this one here, when you cut in these directions, you can see these two graphs. When you are at the middle, it's class the green one correctly. If you are at the tail, you classify the red one correctly.
Doctor, what if in figure the third of point also in dot dot?
Which one? Figure 3 or 2?
Figure
3. The 3 here is this one.
Yeah, but what if we make some changes in figure 3? 2 points are dark points, and what if we make the third point also dark? Then what kind of figure it will make? How much is better?
So means if you have something like this, you can get it correctly. So talk about the third one, right?
Yeah.
So if you have this one here and this one here,
And the top one also these are the same, and one is center.
you mean this one is here, right?
This one is also the blue.
Here.
This one is also the blue one, the top one.
Okay.
Yeah. No. The top one is blue.
Ah, blue. How you can do this one here?
Yeah.
Yes.
Top.
Let me check if we have this one all together. So
Can you
it
classify
will
the
be,
three together?
it will be more ellipse. It will be something like this. Yeah. So it will be 2. It can be 2. In this case, it can be 2.
It means we can classify more than 2 as well.
Yeah, of course, yeah. Here, please. For the following figures, do we need a full covariance matrix, means, or diagonal, mean naive one? What do you think? Means, do you need only vertical, horizontal ellipse, circle, or you need oblique one?
On which figure?
1 and 2 and 3, all of them.
On figure
Do you think we need?
For figure 1, need both.
Figure 1 is clear. You see, from here we have we don't need to have full covariance. Means a diagonal is fine. You see the first one. This is diagonal and this is diagonal. Which one is not diagonal? The oblique one. So the first one, yes, we can, right? The second one, we cannot. If we do circle, circle, there is overlapping or not? Think. Here, in figure 2, in the 2 circle, are we able to do the classification of the training data with 0 error? Yes or no? Yes, because the same scenario. The one at the top, the file is bigger, is higher, the other one is flat. It's something like this, as we did before, right? This is higher and this one is flat. So yes, we can. The next one, third one, they are full covariance, right? Can we make it only diagonal? Mean only vertical, horizontal, or circle? If you do the circle, we cannot, right? Because the circle, they are the same distance to the center, so there is full overlapping, right? Correct? So in this scenario, okay, can we do it just by ellipse, vertical or horizontal?
No.
Think. But we need more than 2, right? Okay. So diagonal is enough for 1 and 2, as we said, and for 3, full is required. Okay. I think there's other questions or not. This is exactly what we did. So this is not comprehensive as last year, so we don't need just here. I need to review this one. Okay, let's do this one here. I don't know if you can see. Suppose you have given data set. You can see all the very small, right? Following data where x and y is very small, right? So suppose you have given the following data where x and y are the two input and class is the output minus and plus. Okay, so below is the data. New slide. Okay, so we plot the data in this way here. Okay, the plotting is here. And the question is, suppose we want to predict the class of x11 using the Euclidean distance 3nn. What would be the class, please? So 1, 1, 1, 1 by using 3nn. Kn with k equals 3. What is the point 1, 1? Is here, right? Yes?
Yes.
So by using 3 nearest neighbor, what will be the class? Plus or minus?
Plus.
It's plus, right? Obvious, right? The 3 are full of them are 3, right? Is more confident. If you want to do with 5, this is 1, 2, 3. What is the next neighbor? Those two, right? So the 5, what is the majority here?
Get plus.
Same thing.
Three
Plus.
is
Same thing, right? So just to make it bigger, okay, is with 7. Please. Let's do it now with 7. With 7. How is this point here? We have 1, 2, 3, 4, 5. So which this one is close to? So we have 6 right now. So the 7, what will be? This one, what will be? 7. Because this one is quite far, right? Pythagorean theorem, right?
Plus and circle both are from the same distance from that.
Yeah, for 7, what do you think? Is it plus or circle? 7 nearest neighbor.
minus.
This is
Minus. Because
Are you sure? I think it's a plus. Let's do it here. Okay, let's do it. 1, 2, 3, right?
Yes.
Here, 4, 5. What's the next one? 6.
and seven.
Next one is 7. This one, right?
Yes.
So how many we have? 4 circle, 3 plus. So it's circle. Circle. So clear idea here? Yes.
No plus
1, 1.
no, okay.
1, okay? Just to see if there's other questions. This we solve it. Here, base, you can do it later. This will be done. Here, for example, can you give me k, value of k? We do kn, that there is 0% accuracy. And give me another k, there is 100% accuracy. So every point I try to classify. This is data set, right? Give me 1k, there is 0 accuracy, and another k, there is 100% accuracy.
From new data.
And data is balanced here, right? Data is balanced.
For doctor, for new data, we have to choose from this one.
Yeah, for this one. This is your data. Give me k where the accuracy is 0, and give me another k where the accuracy is 100%. You can see here the challenge between k. How to classify k and n? Every point here, I will classify this one. First, I will classify this, all of them, one by one, on their own data set.
If K is 9, if K is higher 9, then
I think-
all are important.
So yeah,
Yes.
yeah, develop more. You are in the right.
Yeah,
Yes, you are right. More.
yeah,
Therefore, K equals
Okay, the data is balanced, right?
yeah,
If I choose one of them, the data which will be n minus 1, right?
yes,
So if I take a k, here we have 14.
yes,
If I take k 13, it will be everything, it will be 0 accuracy.
yes,
Why? Look here, take this one here. I took for k 13, mean I look all of them, yes or no?
Yes.
Because they're 13. What is the majority? If I am in the minus, the majority will be plus.
yes,
I will classify it wrongly. Go to the next one. Same thing, same scenario. So if you take k13, mean n minus 1, everything will be wrong. Now look for another side when there is 100% accuracy.
Seven.
If we do 1, look at it. Let's do 1. This is correct classified. This, wrong. You see? What is this point here? We do 1 and n. 1 is level. Which one is close to it?
Plus.
This one, plus. So it should be classified as plus. 2, let's try with 2. This will be 1, 2. We have a lot of conflict. Which one you have to choose? If you use K0 itself, here we have 100% accuracy. So in general, 1K is 0 is always 100% on the training data set if it's labeled. Hmm?
That is true for labeled data.
Of course, and it is labeled, plus and minus. Of course, yeah. They are not the same. It's labeled, of course.
If we take K as 6 as well, we will get 100% accuracy.
6,
Yes.
try it. I don't. Let me check. 1, 2, 3, 4, 5, 6, 7. So if you do 6, those will be 2 mistakes. 2 mistakes. We have 4 mistakes. Because will be all of them. Yes.
Ah, okay. Makes sense.
Okay.
Can you just repeat it? How we, if we choose any random point, how we can?
If we do any random, yes. Here we have to do, for example, in the real one, start with 1, 2, 3, 4 until you get the high accuracy.
So, you compare each one.
Yes, yeah, exactly. For example, here, if you do K, let's do 2, for example, right? 2. Take this point here. How to classify it with 2 and n. Which one is closer to this point? It's plus. What is the next one? Either this or this. They are the same, right? So let's take, for example, let's take 2. This and this. So now you have plus and minus. The same votation. So which one you have to do? Conflict. You cannot say same thing. If you do 3, let's do, for example, 3. How to classify it? 1, 2, 3. So we have 2 minus and 1 plus. So it will be minus, correct. Take this one here. We do it with 3. 1, 2, 3. This would be classified as minus, which is mistake. And you do the calculation in this way.
And doctor?
Yes?
Is this right?
Please, sorry.
What if we replace low to plus with minus and here low to minus with plus?
How to?
What if we replace low to plus with minus? I need to say that 7 minus and 7 plus.
Take K1 or 2 or 3 or 4, they are all full correct. Because they are totally separated. You see it? Done. Take any K. More K, 8, 7, I think.
More than 6 will cause a problem.
Well, 6 will be, yeah, you check it, yeah. Depends, yeah. But 13 for sure is
0.
0. I think anything less than 13 is fine. Because it's easy. Okay, please here, can you find the boundaries if we are using 1 and n? 1 is level. What is the boundaries? The region. That should be class plus and class minus. So it means, what if I am here, it classified to which one? Here, 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 to find new data coming to testing what is the decision tree, the decision boundary. How we do it? With 1 and n. Questions? Try to think.
Okay, the question again?
A decision boundary for 1 and n. At the middle?
Yes. Like
Yes, can be. But here, if we are here, This is belongs to which class? This point. Are you sure?
Oh, with one thing.
I said one and n.
Plus
It's plus. Here.
minus
Here.
plus
Here. Think, yeah, how to do it? What is the boundaries?
Because
If you are 2 plus and minus here, and you do 1 and n, what will be the boundaries? Is that the median, right? The middle. So look at here. What is the decision? It will be at the middle, yes? Anything upper is plus, anything lower is minus. Here, anything at the left is plus, right is minus.
But I think we will go for the minus because the majority is minus.
No, 1 and n. So 1 is there.
One.
We don't look to the other here.
Yeah.
So we are zooming. When we do 1 n, is zooming in, so we don't look overall.
and what is our goal for accuracy?
Sorry?
The goal of accuracy. Accuracy should be 100%.
The?
If the accuracy should not be 100%, then we can go with.
No. The question is only 1 and n. What will be the boundaries? Because here we're talking about the testing, the change. So what will be the boundaries? Let me do it here. I will do only one. Look here. Minus, 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 minus. We have plus, plus, plus. Example, right? What will be the decision here? Anything at the middle is plus and minus, right? Anything at the middle is here. Here, here.
Sir, why we need the boundaries here in this problem?
Sorry?
Why we need to have a boundary line here for this?
Okay. Look here, please. You have plus and minus, right?
I mean, it is only what we count the classes around.
Because I'm using only 1 and n. If you are here, what should be the class? Belong to this one. Look here, take this one here. The same perpendicular, right? Take any point in this point here. It's belong to plus or minus? Here. So this is my boundary. So the same way here, it will be line, 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 and so on. So it will be like this. You see, at the middle is here is plus, minus, plus, minus. So we have 4 regions.
More fitting.
No, we don't. No. Usually, yes, when we have k is too small, we are in the overfitting. Yeah. But in this scenario, maybe not. I cannot say. It's data is small, yeah. But usually, yes, in general, when k is small, we are in overfitting. So clear? This we did last time, right? This one also we did is B. Yeah, okay. So we stop here, I think. It will be
Can you go back 2 slides, please? No, actually forward. So yes, this one. This one we consider that the variance is on x1.
It's bigger.
Here we consider.
Okay. Let's do it here again, please. I will cut. Look here. I will do the cutting here, right? I'll do the cutting here. The variance of B is bigger or not? The center of the B is something like this, right?
Yes.
So I try to do better sketching. A, what will be A, please? A is here. What will be? Yes? And our point is here. It's classified to which one? Which one is bigger? The red one or the blue one, please? So the blue. Clear the idea? So now we can see it in a nice way.
Doctor, here, the same graph we can plot for the x2 or y1.
Exactly. It's a good question. You see here, the point is coming at the center of all of them. So we can say we can neglect x. Yeah.
But it
Okay.
will also be. It will
She
also
said she asked really good questions. Do you think here the covariance is it diagonal or not? Diagonal.
Diagonal.
What does it mean diagonal?
Because
Not correlated. We can do on x and y. And here it's coming exactly on x, so I can consider x and I can neglect the other one. Because they are antidependent or uncorrelated.
But even if we did do the values on x2, we will also get b, because the variance of xb, the probability that it will be in b, it will be higher. Because if we do the distribution on x2,
Let me think. You cut like this. No. Because if you cut like this, you are not touching the point. Because I want to touch the testing point. So your cut should be cross the point. Because I need to calculate the probability at this specific point.
no, I mean,
You see what I mean? If you cut like this,
yes.
I'm looking at all those points. But I want to this point here. So the only cut can do like this, like this, like this. This makes sense. You see what I mean?
Because I'm thinking of the other example that we had two classes and the class in the middle.
Yes.
Remember when we had three circles and then we classified one big cylinder,
Yes.
cylinder and then one in the middle. We said the distribution that the probability that it comes in the middle
Is high.
Is higher. I can imagine it the same here. If I do the A as one class like this and the B like one class like this, and I project the variance on this one, we will get a distribution here for the A bigger, but the variance is very big, and the variance of B will be very small. So the probability of going to the B is higher. If I can draw it. No.
Can you, please, yeah, I'll be happy, yeah, check it. So we will stop here, all the questions, and we try to, either we meet on Thursday, either way I'll prepare some question solutions, please. Okay? Yeah. The blue one better, yeah.
If we do this, will be the V.
So, what is your cut?
It's an X2.
Oh, it's okay.
This will be something like. And
You cut here.
yes,
If you cut.
this is the B, and this will be the A. Something. Yeah. So if the point is here, the probability that it's going to A, which is this one, is higher than B, this one. Similar to the cylinder that when we had two classes.
Similar, yeah.
Yeah, when we said two classes, one class in the middle.
Yes. Yeah, I agree with you, yeah.
Right?
Yeah, he said really nice idea, yeah, I agree with you. Do you agree with that, what he said?
Yes.
If you do the projections on the x-axis, you will get exactly the two curve here. Yeah, thank you so much. I think it's correct, yeah, totally correct. So you can do it here. For me, I think, yeah. So there's two ways, yeah, thank you. So we do the projections because they are diagonal matrix. If you do the projection, what will be here? This is for, no, the opposite, not A and B. The opposite, right? Yeah. So here will be B, it is, and this will be A. Yes, exactly. Yeah. Okay? Yes, correct. Yeah, it's much easier, yeah, I agree, much easier than mine. Thanks.
So here, in the question, should it be clear in the question that we want to project the data on the x1? Or
The question is just like this here. How to classify based on
what
it.
if it is different? Projecting it to x different than x1?
It's the same thing. If you project on x1, you get this, as I said. If you project on x2, it's much better. It's clear. It's obvious. Yeah, but both are correct. But here you do the projection because they are diagonal matrix. Otherwise, no way. Okay. Thank you. Wish you a good semester. All the best, inshallah.
I did just for those slides, they will be on the.
Yeah. I'll post them on.
Please.
I will update it. Yeah. Thanks. Yeah? I will check with Abu Bakr. I will post it by tonight. We'll see. Our exam is Sunday, right? Right? time, it was 1 minute. The time for